In a groundbreaking statement that could reshape our place in the universe, NASA has announced the detection of the first extraterrestrial signals emanating from the direction of Proxima B. This exoplanet, the nearest known to Earth, is located just over 4 light-years away, positioned within the habitable zone of its star, Proxima Centauri. This revelation has ignited an immense surge of excitement and curiosity around the globe. Could this be the pivotal moment when humanity realizes it is not solitary in the cosmos? The journey to this monumental discovery began with careful and detailed observations by NASA's advanced telescopes, which have been relentlessly scanning distant stars and planets in search of signs of life. Proxima B has long been a prime candidate in the search for extraterrestrial intelligence due to its Earth-like qualities and its proximity to our solar system. The detected signal stands out as something entirely distinct and unfamiliar to astronomers, marking a potential turning point in human history. The consequences of such a discovery are immense. Firstly, it affirms the long-held scientific theory that life may be possible on other planets under conditions similar to Earth's. Secondly, and perhaps more tantalizing, it provokes the question of the types of civilizations that may exist there. Could they be mere microorganisms, or could they be advanced entities with the capacity for interstellar communication? This signal from Proxima B is far more than just random noise or a natural cosmic event. It exhibits a clear, repetitive pattern that strongly suggests an intelligent origin. Scientists from NASA and other international teams are now working tirelessly to decode this message, attempting to understand its meaning and any potential intentions behind it. The global scientific community is abuzz with theories and speculations about the message's content. Could it be a greeting, an invitation, or something entirely unfathomable? News of this discovery has reached beyond the scientific community, sparking passionate debates on social media, within government halls, and even around dinner tables across the world. People are now gazing at the stars with renewed awe, contemplating the possibility of other beings on distant planets who might be pondering the same questions. How similar or different could their world be to ours? What might their society look like in terms of technology and culture? The possibilities seem as vast as the universe itself. Moreover, this detection raises several profound ethical and existential dilemmas. How should humanity respond if these signals truly originate from intelligent beings attempting to communicate? What protocols should we develop for interstellar diplomacy? Most crucially, how would such a discovery alter our understanding of religion, life, and our very identity as human beings? While excitement continues to build, there is also noticeable caution at NASA and other space agencies, who are working meticulously to confirm the authenticity of the signals and eliminate the possibility of a false positive or misinterpretation. We stand on the cusp of what could be the most significant discovery in human history. Therefore, every next step must be carried out with care, accuracy, and responsibility. The world waits expectantly for further analysis, hoping to uncover more details. The detection of signals from Proxima B could not only propel our scientific endeavors into a new era but also unite humanity in a shared sense of wonder and hope. We may be on the verge of answering one of the oldest and most profound questions. Are we truly alone in the universe? In April 2019, a radial signal was detected coming from space, specifically from the Proxima Centauri region, which lies 4.37 light-years from Earth. While this distance may seem substantial, it is the closest known star to the Sun, situated approximately 3 times farther away than the third brightest star visible in our sky. The signal originated from a triple star system, which includes the binary pairs of Alpha Centauri A and B, as well as Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, the 2 stars within this system, are relatively close to one another and are quite similar to our Sun. Alpha Centauri A shines with a yellow light and is about 1.5 times brighter than the Sun, while Alpha Centauri B is slightly dimmer, emitting an orange hue. Alpha Centauri A is slightly larger than the Sun, while Alpha Centauri B is smaller, with our Sun falling between the two in size. But where did this mysterious signal come from? In the midst of these stars, the Breakthrough Listen project, dedicated to searching for extraterrestrial communication, has designated the signal as Breakthrough Listen Candidate 1, BLC-1. The project, funded with approximately $100 million, has utilized thousands of hours of observation using cutting-edge telescopes located worldwide. The signal was initially detected by the Parkes Radio Telescope in New South Wales, Australia, while it was monitoring the Proxima Centauri region, the closest star to the Sun. The signal almost went unnoticed among the vast amount of data collected, but scientists were able to identify it, akin to finding a needle in a haystack. For the signal to be considered noteworthy, it must meet 2 critical criteria. Firstly, It must be confined to a narrow frequency range since radio signals of this type are not typically produced by natural phenomena in space. Secondly, the frequency should fluctuate in accordance with the relative motion of the exoplanet in relation to Earth. The scientists had to sift through nearly 4 million individual signals gathered by the telescope in Australia. After an exhaustive process of filtering and removing irrelevant signals, they identified around 5,000 distinct signals, with one standing out. This particular signal could not be explained after cross-referencing it with known terrestrial radio transmitters. It was unique, with a narrowband technological signature, and was only detected when the telescope was directed at Proxima Centauri. The signal persisted over a 30-hour period. Upon further examination, it was determined that the signal originated from Proxima B, an exoplanet discovered in 2016 using the radial velocity method. This method detects variations in a star's position due to the gravitational pull of orbiting planets. The star traces a small circle, and highly sensitive spectrographs are used to analyze the starlight. As the star approaches a planet, its spectrum shifts slightly toward blue, and as it moves away, it shifts toward red. When these shifts occur consistently over days, months, or years, they indicate the gravitational influence of an orbiting planet. On closer inspection, Proxima B appears strikingly similar to Earth, with a radius 1.1 times that of Earth and a mass 1.3 times greater. This suggests that it is a rocky world with a similar density. However, there are notable differences. For instance, Proxima B orbits much closer to its star, only 0.05 astronomical units away, while Mercury, the closest planet to our Sun, is situated at 0.39 astronomical units. This proximity makes Proxima B an exceedingly hot planet. Nonetheless, because Proxima Centauri is a red dwarf star, the planet only receives 60% of the energy that Earth receives from the Sun, placing it within the habitable zone, where life could potentially thrive. Despite Proxima B's position in the habitable zone, there are significant challenges to its ability to support life. One major concern is stellar activity. Proxima Centauri, being a red dwarf, is known for its intense solar flares, which can emit bursts of high-energy radiation. These flares have the potential to strip away a planet's atmosphere over time, making it difficult for life as we know it to survive. Scientists are now investigating whether Proxima B has a strong magnetic field or an atmosphere dense enough to shield it from such radiation. If the planet retains an atmosphere, it could harbor liquid water, one of the key ingredients for life. Some models suggest that Proxima B might have a tidally locked orbit, meaning one side always faces its star while the other remains in perpetual darkness. If so, this could create extreme temperature differences, but there could be a habitable zone along the terminator, the region between the planet's day and night sides, where conditions might be more stable. The implications of the signal. The discovery of a potential extraterrestrial signal has reignited philosophical, scientific, and ethical debates. If the signal is truly of intelligent origin, it would confirm that we are not alone, a realization that could fundamentally alter humanity's understanding of its place in the universe. Scientists are now working on deciphering the signal. Is it a simple beacon? A form of greeting? Or perhaps something more complex, an attempt at interstellar communication? Some researchers suggest that the signal could carry encoded information, potentially containing mathematical patterns or universal scientific concepts. Others speculate that it might be a distress call or a remnant of an ancient civilization. If the signal's origin is verified, humanity faces a critical question: should we respond? Some experts argue that broadcasting our existence could be risky, as we have no way of knowing the intentions of the civilization on the other end. Others believe that remaining silent is not an option, as the opportunity to engage in interstellar diplomacy could be the most important moment in human history. A new era of exploration. In response to this discovery, space agencies around the world, including NASA, the European Space Agency, ESA, and private organizations like SpaceX, are increasing efforts to develop new methods for interstellar exploration. Projects such as Breakthrough Starshot, which aims to send light-powered nanocraft to the Alpha Centauri system, could provide direct observations of Proxima B within a human lifetime. Advanced telescopes, such as the James Webb Space Telescope and the upcoming Extremely Large Telescope, ELT, are also being directed toward the region, analyzing Proxima B's atmosphere for signs of life, such as oxygen, methane, and other biosignatures. Meanwhile, discussions about the future of humanity's role in space are gaining traction. Some scientists propose that if Proxima B proves to be habitable, it could become a target for human exploration or even colonization in the distant future. Although the challenges of interstellar travel are vast, breakthroughs in propulsion technology, such as nuclear fusion and antimatter propulsion, may one day make such journeys feasible. Awaiting the next revelation. As scientists continue analyzing the signal and exploring the mysteries of Proxima B, the world watches with a mix of awe, excitement, and caution. The implications of this discovery extend beyond science. They touch on our deepest existential questions. What if we are not alone? How would contact with another civilization reshape our societies, beliefs, and future? Are we ready for what comes next? While definitive answers remain elusive, one thing is certain: humanity stands on the threshold of a new cosmic era. The coming months and years may bring new discoveries, unexpected challenges, and perhaps, the first steps toward interstellar connection. Until then, we continue to gaze up at the stars, listening carefully, waiting for the universe to reveal its secrets. Planets are scattered across the universe, many still undiscovered. To date, we have identified an impressive 4,935 exoplanets and recently added 65 new planets to the roster, bringing the total number to 5,000. This latest group of 65 exoplanets was included in NASA's Exoplanet Archive on March 21, marking a significant milestone in planetary exploration. The James Webb Space Telescope, JWST, the most advanced telescope ever constructed, is about 100 times more powerful than its predecessor. With its assistance, we will be able to unlock the mysteries of the vast universe. Over time, we've discovered a diverse range of planets, from small rocky worlds to gas giants larger than Jupiter, as well as extremely hot planets and those capable of supporting life. Among these discoveries, a few planets stand out, such as Kepler 1649c, which bears striking similarities to Earth. It is currently considered the most habitable planet we've found, and it may harbor life. Thus far, we've identified 55 Earth-like planets, but we have not yet been able to study all of them in depth. With the rapid advancement of technology, especially with the JWST, who knows what new discoveries lie ahead? Imagine the possibility of finding a planet capable of supporting life. One of the main goals of the JWST during its first year of operation is to locate and study extraterrestrial worlds beyond our solar system, focusing on their formation and the possibility of life-supporting conditions. Webb's research on star and planet formation allows us to link studies of mature exoplanets to their birth conditions, as well as tie our own solar system to their origins. Webb's infrared capabilities are ideal for observing how stars and planets are formed for several reasons. Infrared light penetrates dust well, detects the thermal signatures of young stars and planets, and helps identify essential chemicals like water and organic compounds. Mid-infrared light can pass through clouds up to 20 times denser than visible light, which is crucial when studying newborn stars hidden within their birth clouds. These capabilities are essential for understanding the early stages of star formation, as gas and dust collapse to form young stars. Moreover, both young stars and massive planets emerge as vast, swollen structures that gradually contract over time. As they age, newborn stars heat up while giant planets cool down. Both, however, emit more light in the infrared spectrum than in the visible range. This means that the Webb telescope is particularly well suited for discovering new stars and planets, as well as shedding light on the physics of their formation. Using its MIRI instrument, Webb will also search for hot molecular gas around numerous young stars, which may suggest the formation of habitable rocky planets. Not surprisingly, much of the JWST's early scientific endeavors will focus on understanding how planetary systems develop and identifying molecules that could be crucial for the emergence of life. As the James Webb Space Telescope, JWST, delves into its research, it is poised to unlock the secrets of planets that may harbor life. The telescope's advanced infrared capabilities are crucial for capturing vital data from young stars, which are often shrouded in dense clouds of gas and dust. By observing these stars and their surrounding environments, scientists will gain a deeper understanding of how planets form and whether they possess the right conditions to support life. Webb's ability to detect the thermal emissions of young stars and planets will be pivotal in identifying those that may hold the potential for life. These observations will also reveal the chemical signatures of these celestial bodies, providing insights into the building blocks of life. The infrared spectrum allows Webb to study regions of space that are otherwise hidden from traditional telescopes, enabling it to peer into the heart of star formation and planet development. The telescope's investigations are not only focused on the study of distant exoplanets but also on understanding the formation of planetary systems as a whole. Webb will explore the conditions necessary for life to emerge, seeking to identify essential elements like water, organic molecules, and other compounds crucial for life's origin. This research could eventually help determine if there are other planets that could support life in the same way that Earth does. As humanity continues to push the boundaries of space exploration, the JWST represents a critical tool in our search for answers to some of the most fundamental questions about the universe. It will enable us to explore previously uncharted territories and gain insights into the early stages of star and planet formation. The discoveries made by Webb could redefine our understanding of the cosmos and our place within it, offering hope for the discovery of life beyond Earth. The James Webb Space Telescope is not only a marvel of technological achievement, but it is also a symbol of humanity's relentless curiosity and desire to understand the unknown. Its observations will shape the future of space science, allowing us to explore distant worlds and uncover the mysteries of our universe. As we look toward the future, we remain hopeful that the answers to some of our most profound questions lie just beyond the stars. In the coming years, the JWST will continue to push the boundaries of what we know about the cosmos. By studying distant stars, exoplanets, and the building blocks of life, it will help us better understand the potential for life on other planets and the conditions necessary for it to thrive. As we venture deeper into the universe, we are reminded of the vastness of space and the infinite possibilities that lie ahead. The discoveries made by the James Webb Space Telescope will undoubtedly have a profound impact on humanity's understanding of the universe. By exploring distant exoplanets and star-forming regions, we will gain valuable insights into the processes that govern the formation of planets and stars, and the potential for life elsewhere in the cosmos. As we continue to explore the stars, we are reminded that our journey is just beginning, and the universe is filled with endless opportunities for discovery. As technology advances and our understanding of the cosmos deepens, the James Webb Space Telescope, JWST, will continue to serve as our window into the unknown. Beyond identifying exoplanets and their atmospheres, Webb's mission extends to studying the formation of galaxies, black holes, and the fundamental forces that shape the universe. One of the most exciting aspects of Webb's work is its ability to study the first galaxies that formed after the Big Bang. By capturing the faint light from these ancient structures, Webb is allowing scientists to peer billions of years into the past, uncovering the processes that led to the formation of the universe as we know it. This unprecedented look into cosmic history could answer long-standing questions about how galaxies evolve and whether conditions similar to those of the early universe exist elsewhere. Additionally, Webb's ability to analyze the atmospheres of exoplanets is a game-changer in the search for life beyond Earth. By detecting specific chemical signatures, such as oxygen, methane, and water vapor, scientists can determine whether a planet has the necessary conditions to support life. Some of the most promising targets include planets within the habitable zones of their stars, regions where temperatures allow for liquid water to exist. Future missions may work in tandem with Webb to further investigate these exoplanets. For example, upcoming observatories, such as the Nancy Grace Roman Space Telescope and the European Space Agency's Ariel mission, will complement Webb's findings by conducting large-scale surveys of exoplanetary atmospheres. Together, these instruments will refine our understanding of planetary formation, habitability, and the potential for extraterrestrial life. Beyond exoplanets, Webb's ability to study our own solar system is equally significant. Scientists are using its infrared capabilities to observe the outer planets, their moons, and even distant objects in the Kuiper belt. Webb has already provided new insights into Jupiter's Great Red Spot, Saturn's icy moons, and Neptune's faint rings. As we explore these celestial bodies, we may uncover evidence of subsurface oceans, organic molecules, or even primitive forms of life. As the telescope continues its mission, each discovery will contribute to a larger understanding of the cosmos. The search for life, the study of planetary evolution, and the exploration of the universe's origins all point to a future filled with scientific breakthroughs. The James Webb Space Telescope is more than just an instrument, it represents humanity's insatiable curiosity and our collective desire to understand the universe. With each observation, we inch closer to answering age-old questions. Are we alone? How did the universe begin? What is our place in the vast cosmic expanse? As we continue our journey among the stars, the JWST will serve as our guide, illuminating the path toward new horizons. The discoveries it makes today will shape the future of space exploration for generations to come, inspiring new missions, new technologies, and new dreams of venturing even deeper into the cosmos.